Hello ulit everyone. So welcome again in my YouTube channel, and yung topic ko for today's video is about the energy in a flowing fluid and heads and Bernoulli's energy theorem. So let's talk about the energy. So alam na natin ito from mechanics that we have kinetic energy and potential energy. Okay? So basically, yun din naman ang meron tayo sa hydraulics, sa fluid mechanics. So kinetic energy, as we know, is equal to 1/2 times the mass and the velocity squared. While the potential energy, so this is equal to mgz. Okay? So kung ito yung reference line, which is yung ating datum, and then say meron tayong object at this elevation with a height z. Ayan. So yung potential energy is mgz, or this is also equal to m and g is equal to the weight times z. In fluids, so meron pa tayong isa pang form ng energy, so which is yung energy from the pressure. Sa ibang book, consider pa rin siyang part ng potential energy. Kasi kinetic is basically meron tayong movement. So yung pressure, pwedeng may pressure naman doon sa fluid pero wala pa rin flow. So that can still be considered a potential energy. Energy from pressure. Pressure energy. So this is equal to, so this is equal to the weight and the pressure head, which is yung pressure over the unit weight. So this is itong term natin ng pressure head. So na-discuss na to sa fluid mechanics. So this is normally in meter kapag metric. So para-pares naman sila ng unit. Ang unit ito is it can be Newton meter. Ito rin, pwede rin itong Newton and meter. So same lang din dito. Weight is Newton, pressure head is in meter. Okay, but in fluid mechanics or in hydraulics, particularly sa civil engineering, so yung mga energy is mas madaling mag-solve ng mga energy if it is in terms of what we call yung head. So ito na nga yung pressure head natin. So yung head is actually yung energy per weight. Okay, so let's say meron tayo ditong pipe. Okay, and so ito yung ating datum. Then let's say we have 0.1, and then this is our 0.2. Okay, so this has an elevation z1. Then this has an elevation of z2. Okay, then meron tayong flow. So at 0.1, okay, so energy at 0.1. So the total energy in 0.1 is, so kung meron tayong discharge Q, meron tayong velocity. So kung may velocity, meron tayong kinetic energy na equal to 1/2 mv squared. Okay? And then, meron tayong pressure. If this is a closed conduit, so meron tayong pressure dyan. So meron tayong energy from the pressure. So that is the weight. Okay? Then, P over unit weight. And then, since meron tayong elevation, Z1, so meron tayong potential energy na equal to mgz. So, in civil engineering, so yung energy natin are expressed in terms of heads. Okay? So, if we divide all this by the weight, okay, so for the kinetic energy, so if we divide yung 1/2 mv squared ng weight but weight is equal to, diba, weight is mass times gravity. So we can cancel yung mass, then this will become v squared over 2g. Okay? While this one, we can cancel directly yung weight. So plus the pressure head, pressure over the unit weight, and then mg is weight divided by weight. Okay, so this is Z1. Okay, so that's the total energy at point 1 per weight. Okay, so yung v squared over 2g is called the velocity head. So the head coming from the flow, okay? Because of the velocity of the fluid or the liquid. Then yung pressure over the unit weight, this is called pressure head. While yung elevation z, so this is called the so we can call that elevation head. Okay? Okay, so let's proceed naman dito sa power and efficiency. So we know that power is yung rate at which a work is being done. Okay? So power is work per time. Okay? So gaano siya kabilis na ginagawa. Okay? So work is, as we know, is equal to force times distance. And distance, of course, is yung distance na along sa direction of force. Then over time. Then we can see here na meron tayong distance over time. So this is actually a velocity. Okay? So now power will be equal to the force times the velocity. So in fluid mechanics and hydraulics, ano ba yung madalas na concern natin kapag meron tayong flow, meron tayong pipe? Okay? So basically, ang mas concern natin when it comes to hydraulics is the pressure. So how do we solve force in terms of pressure? So yung force, so di ba ang pressure is equal to force over area? So force is equal to pressure times area. Okay? So pressure times the area. Okay? So let's say meron nga tayong pipe, then ito yung let's say circular pipe, no? Ayan. So ito, let's say yung volume of liquid that is flowing. So kumuha lang tayo ng isang controlled volume. So meron tayong cross-sectional area and meron tayong force. So meron tayong pressure. Okay? So yung pressure basically yung nagpapa-flow. Yung imbalanced pressure yung nagkakos sa fluid para siya mag-flow. So definitely meron din kasing pressure dito sa kabilang side. Pero kung mas malaki yung pressure dito sa left side as compared sa right side, then this volume will flow. Okay? So pressure times area times velocity. So parang familiar to, no? Area times velocity. Diba this is discharge Q? Okay? So unahin ko muna yung discharge Q. And then pressure, paano ba natin nakukuha yung pressure sa fluid mechanics? So in fluid mechanics, kung meron tayong let's say point at certain depth. Okay? So let's say this is height h. So to solve for the pressure at this point, so that is equal to the unit weight times the height h. Okay? So this is if it's static. So yung energy natin or yung head that causes the pressure on this point is just this height h. Okay? Pero in this case sa hydraulics, since meron tayong flow, so again pressure is the unit weight times the height or the head. Diba? That is yung head. So in this case, since meron tayong flow and kinoconsider na at marami na tayong kinoconsider ngayon, So, meron nga tayong pressure head, elevation head, and velocity head. So, lahat yun is yung total head. So, ang gagamitin natin ngayon dito is the total energy at that point. Okay? So, power is equal to the discharge Q, the unit weight of the liquid, times the total energy in terms of head. So, ito yung ating power. So, what about yung efficiency? So, efficiency is yung ratio ng output power doon sa with respect sa input power. So, multiply natin ng 100% para maging percentage yung ating efficiency. So, this should be less than 100% kasi hindi pwedeng mas malaki yung output yung lumalabas dun sa system na power kaysa dun sa binigay mong power. Okay? So, in most cases, normally meron tayong mga energy na nagiging waste kasi nagiging heat, diba? So, kumbaga nakawala siya dun sa system in terms of heat. So, yung output is always lower than the input power. So, kung sa pump, kung meron tayong pump, so, meron tayong flow, nilagay tayo dito ng pump. Okay? So, ano yung input ng pump? So, diba yung pump is pinapagana by using electricity or fuel. So, tulad dun sa sprinkler system. So, pwede siyang paganahin ng generator. Then, ang output nito is yung energy na magbibigay ng flow ng water dun sa mga pipe. Or pwede naman yung pump is diesel powered. So from the fuel, so siya yung magpapaandar dun sa pump, and then yung pump will give energy doon sa flow. So meron naman tayong turbine. So yung turbine naman, so normally nasa dam, di ba? So meron tayong let's say pipe, then pababa dyan. So, nasa loob yan ng dam. Okay? Then, may turbine doon sa loob. So, ano naman yung input sa turbine? So, yung input sa turbine is galing doon sa energy from flow. From the flow of liquid. Okay? So, yung total energy na yan. So, meron tayong velocity head, may pressure head tayo, and elevation head. Then, yung output naman, ano yung output ng turbine? So, bakit tayo naglalagay ng turbine? Sa mga hydroelectric power plant, sa mga dam, diba? So, yung flow is being converted to electricity. So, baliktad naman. So, sa pump, electricity, yung input, ang output natin is yung added energy dun sa flow. While sa turbine naman, so kumukuha naman siya ng energy from the flow, then ang magiging output natin dyan is electricity. So kung ano yung energy, total energy na kinuha niya dun sa flow, so hindi niya maibibigay ng 100% yung same energy na kinuha niya in terms of the electricity. So mas mababa na yung total na power na magiging output. So ganun din naman dito sa pump. Okay? So, let's talk now about the Bernoulli's energy theorem or Bernoulli's energy equation. Okay. So, in an ideal flow, so discuss muna natin to, no? So, this is called, this represents yung okay, so that is energy grade line, while this one is so meron tayong tinatawag na energy grade line or then this one is HGL. So ano yung dalawa na yan? So yung energy grade line is yung kung ipa-plot natin, no, i-graph natin yung total energy, okay, so total energy ng flow, okay? So in this case, this is without head loss. So walang nawala walang naka-escape na energy doon sa system natin. So that is yung ideal flow, pero hindi naman yan nangyayari, no? So kaya dito sa baba, ito naman is, so this is with head loss. So may energy in terms of head na nakaka-escape, no? So again, that is in the form of heat. Okay? So ano yung energy grade line ulit? Again, that's the total energy. So if this is yung ating datum, itong black na line na to, if that is our reference line, so ano-ano ulit yung mga energy natin? So again, let's say this is 0.1, this is 0.2. So sa point na yun. So ano-ano yung energy na meron tayo sa flow? Unahin ko na to, this is yung elevation head. Okay, so Z1. And then, hanggang dito sa may hydraulic grade line, ito naman, itong height na to, ito naman yung ating pressure head. So, ang pressure head is pressure over the unit weight. So, ano pang energy ang meron tayo sa flow? So, diba, velocity head. So, ito naman yung nire-represent itong height na to. So, this is yung V squared over 2G. So, kung nasa point 1 tayo, piece of 1, pressure 1, velocity 1. So, if we neglect yung head loss, so yung energy grade line should be horizontal. Okay? Should be horizontal or same height all throughout with respect to the datum. Okay? So, ito yung total energy sa point 1. Then, ito naman yung total energy sa point 2, again, without head loss. So, kung hindi natin consider yung head loss. So, dito makita natin na ito tumaas yung elevation natin from point 1 to point 2. This is Z2. Okay? And yung diameter natin, this is bigger diameter, then naging mas smaller diameter siya dito sa dulo. So, yung na-discuss natin dun sa fundamentals, no? Fundamental of flow. For a continuous flow, if yung diameter or cross-sectional area is lumiit, then the velocity, okay, so the velocity will increase. So, makikita rin natin dito yan. So, ito ngayon yung velocity head natin, itong height na to. So, dito, mas malaki na yung height ng velocity head. V2 squared over 2G. Okay? And then, yung pressure natin at this point, yung pressure head, makita natin is lumiit na. Okay? So, sa fluid mechanics, alam natin na kapag as we go down, pressure increases. If we go up, yung pressure decreases. So, kaya makita natin yung pressure head dito, since umangat tayo, is lumiit. So, this is yung pressure 2 over the unit weight. So, lumiit yung pressure head dito sa point 2. Number 1 is dahil tumaas yung elevation. Then, another reason is because bumilis yung velocity. So, pag bumilis yung velocity, yung pressure natin is nagde-decrease din. Okay? So, may magandang demonstration dito, no? Or yung flow measuring device natin na Venturi meter. So, madidiscuss natin yun sa next topic. So, doon na-prove, no, by using that Venturi meter na pwede nyo rin na may search sa YouTube about Venturi meter. So, this will demonstrate na yun nga, if yung velocity increases, then the pressure decreases. Okay? So, what about sa flow with head loss? So, again, from this figure, energy at point 1 is equal to the energy at point 2. Yung total energy sa point 1 is equal to the total energy at point 2. So, basically, yan pa rin naman yung conservation of energy. So, applicable pa rin siya dito. Okay, so ngayon dito meron tayong head loss. Medyo binago ko lang yung type. It's going down naman. Okay, so, again, this is yung energy grade line. Then this is yung hydraulic grade line. So, ano ba magandang representation din ng hydraulic grade line? So, kung meron tayong pipe, no? And then, kung maglalagay tayo sa kanya ng bubutasan natin to, tapos mag-connect tayo ng pipe. Because may pressure dito sa loob, yung water will rise dito sa loob. So, aangat siya dun sa loob. Aangat siya hanggang dito sa may hydraulic grade line. So, aangat siya hanggang dyan lang. So, kung lalagyan pa natin ng marami pa tong ang tawag natin actually dito is piezometer. This one. Ayan. So, yung straight pipe. So, kung maglagay ka rin dyan, maglagay ka dito, maglagay ka dyan ng pipe, butasan mo dyan, i-connect mo siya. Ayan. So, yung water level or yung liquid level will rise hanggang dito sa may hydraulic grade line. Okay? Baliktarin lang natin. Kung maglagay tayo ng pipe, ng piezometer dito sa pipe natin, so because of the pressure, mag-aangat, magra-rise yung water level hanggang sa mga levels na yan. Then, if you connect those water level, so yan na nga yung ating hydraulic grade line. Okay? So, again, meron tayong, of course, this is elevation head, this is pressure head, P1 over gamma, and then this is yung velocity head, V sub 1 squared over 2G. And because lumiit ulit yung diameter dito, sumata natin na tong velocity head natin, V sub 2 squared over 2G. So, lumaki yung height niya, So, lumaki yung velocity head dahil bumilis yung flow. So, although, sabi nga natin, Z2, yan. So, habang bumababa tayo, lumalalim tayo sa liquid, so yung pressure increases, pero mata natin dito yung pressure is almost the same dito, Of course, hindi naman accurate itong graph ko. So, this is P2 over unit weight. And so, almost the same sila, kahit bumaba tayo doon, parang mas malaki pa nga itong P1 over gamma. It's because, yun nga, as the velocity increases, the pressure decreases. Okay? So, yung ibang energy na galing sa pressure head is being converted to velocity head or kinetic energy. Okay? And at the same time, yung flow natin, so every time na meron tayong flow, nagkakaroon yung system natin ng head loss. Okay? So, yung decrease, okay? So, yung decrease in the energy, total energy, or yung pagbaba nitong energy grade line, represents yung ating head loss. Okay? So, how do we write yung energy equation with head loss? So, yung without head loss, ito lang yon. And, again, without head loss, energy at point 1 is equal to energy at point 2. So, this is just equal to V1 squared over 2G plus pressure 2 over the unit weight, then plus pressure 1 over the unit weight, then plus Z1. Then this will be equal to energy at point 2 is V2 squared over 2G plus P1, P sub 2, pressure 2 over gamma, then plus Z2. Okay? So, what about kung merong head loss? Okay, so with head loss, from this graph kasi, namata natin na, again, ito yung energy at point 1, total energy at point 1. From the datum or the reference line hanggang dun sa may energy grade line. So, dito naman, ito yung ating total energy at point 2. Okay? And then, meron ngayon tayong head loss dito. So, yung kanina, so, pantay yung energy 1 at energy 2. So, without head loss. So, dito naman sa second is, mata natin na with head loss, then energy at point 1 is equal to energy at point 2, plus yung head loss. So, pwedeng ganito mo siya isulat kung titingnan mo itong based on this graph. Okay? So, mas maliit na yung energy at point 2. So, because meron na nga tayong head loss. Pero ako kasi masanay ako na, so magsisimula ako sa point 1, so energy at point 1. Then, pag dumaan ako dito sa pipe, basta dumaan ka sa pipe, meron kang friction and magkakaroon ka ng head loss. The longer the pipe, the greater the head loss. Okay, so kapag dumaan ka, so assuming na ito yung flow, no? So kapag dumaan ka sa pipe, magkakaroon ka ng head loss, and yung head loss is nababawasan yung energy. So that's why magsusubtract ako dito ng head loss. Then, saan ako nakarating? Sa may point 2. Then, this will be equal to the energy at point 2. So, parang tinranspose ko lang naman ito sa kabilang side ng equation. So, kaya siya nag-minus. So, mas ganito lang kasi yung prefer ko. Kasi if meron kang pump dito, so, somewhere along the length ng pipe is meron siyang dadaan ng pump. Okay? So, energy at point 1, duman ako sa pipe. So, meron akong friction. Okay? Then, so, halimbawa ito, naglagay ako ng pipe doon. So, energy at point 1. Then, hatiin ko to sa dalawa kasi magkaiba siya ng diameter. Okay? So, kung magkaiba to ng diameter, pwede ko itong gamitin, consider na length 1, then yung kabilang side is L2. Then, dumaan ako dun sa L1, sa pipe na may length na L1. So, meron akong head loss 1. So, pag dumaan ka sa pipe, magkakaroon ka ng head loss. Then, dumaan ako sa pump. Ano yung ginagawa ng pump? It adds energy or head doon sa flow ng fluid. So, magkakaroon ako ng additional head. So, pump is, yung energy ng pump is represented by HA or head added. Or pwede mo naman lagay dito na head ng pump. So, any symbol naman na gusto mo. So, pwedeng HA. So, this is head added. Okay? Or pwede naman HP kung yun ang gusto mo as head ng pump. Okay? Then, dumaan ulit ako dito sa another section nitong pipe with a length L2. So, magkakaroon ulit ako ng head loss. May mababawasan ulit yung energy. Okay, so, minus again ng head loss 2 sa pipe 2 or sa section 2. Then, nakarating ako ngayon sa point 2. Then, this will be equal to energy at point 2. And so, mas prefer ko personally yung ganito. Kasi yung titignan mo siya magkabilang dulo. Okay, then saka mo titingnan na okay, energy at 2 plus HL. So basta kung ito yung direction of flow, so ina-analyze ko yung pipe along the direction of flow. So pag may dinaanan yung flow na pipe, so meron kang head loss, dumaan ka sa pump, mag-increase ngayon yung head, then another head loss dahil dumaan ka ulit dito sa section 2 ng pipe. Okay? So, eto naman meron tayong pipe with a constant diameter. So, for a pipe with a constant diameter, yung energy grade line and yung ating hydraulic grade line will be parallel. Parallel lang yung dalawa yan. Kasi, di ba pagka constant diameter, then yung velocity will be constant. So, sabihin, eto, V squared over 2g. So, that will be yung pressure, yung velocity head natin at any point is constant. Kasi constant naman yung velocity. Yan. So, para-paras lang to ng height. So, kahit pagdating dito sa dulo, v sub 2 squared over 2g. But since velocity 1 is equal to velocity 2, so, pwede mo namang alisin na itong subscript na 1 and 2. So, in this case, meron tayong head loss kasi mata natin na yung energy grade line natin is sloping down. Okay? So, kung meron tayong pressure head dito sa point 1, P over gamma, pagdating dito sa point 2, yung pressure 2 over gamma natin or yung pressure head natin is mas mababa na, no? Compared dun sa point 1. It's because meron nga tayong, yung decrease ng energy grade line. So, ito yung ating head loss. So, kahit yung pipe natin is i-incline natin, katulad nito, okay? So, in-incline ko yung pipe going up. So, let's say ito pa rin yung flow. Ayan. So, yung head loss natin is yun pa rin. Okay, so, ito pa rin yung head loss. And, ito pa rin yung ating velocity head, v squared over 2g. So, constant diameter. So, ito pa rin yung v squared over 2g. So, makikita natin na yung pressure head, ito, this is P2 over gamma. And then ito yung elevation head, Z1. This is Z2. So, pag tumaas yung elevation, alam natin definitely na mababawasan yung pressure. But, at the same time, since meron tayong head loss, so yung total na potential energy natin, which is yung Z1 and P1 over gamma, is nabawasan din. So, ito rin naman yung, since this is constant diameter, then yung energy grade line is parallel sa hydraulic grade line. So, ito rin yung this is also yung ating head loss. Ito rin yung head loss. Tama? So, pares lang to. Okay? So, that is yung ating energy equation ng flow with and without head loss. So, what if meron tayong, so let's say meron tayo ditong pump. Then, let's say ito yung ating, so meron tayong head loss, no? So, consider natin yung head loss. So, because of the head loss, yung ating energy grade line will be sloping downwards. Okay? Until makarating tayo dun sa may pump. Then, dahil may pump, yung pump is giving additional head dun sa ating flow. So, biglang aangat dito ngayon yung energy grade line. Okay? Kasi nga nagkaroon tayo ng head added. And then, may flow ulit tayo dito sa pipe na to. So, dahil may flow, merong head loss. So, mag-slope ulit to pababa. Okay. So, yan yung magiging graph ng ating energy grade line. So, what about yung hydraulic grade line? So, if this is constant diameter, so, yung hydraulic grade line will be parallel, di ba? Kapag constant yung diameter, kasi constant yung flow. So, medyo i-modify ko lang to. So, just before ng pump and paglampas ng pump. Ayan. So, yung hydraulic energy grade line. So, pagdating niya sa pump, pagpasok niya, paglabas niya mag-increase yung ating total energy. While yung ating hydraulic grade line, so again, since constant yung diameter, then yung hydraulic grade line will be parallel sa energy grade line. And may head loss, so kaya nga bumababa yung ating pressure, no? And then, dahil may pump, so mag-a-add ng energy yung pump doon sa flow. Then, tataas din yung ating hydraulic grade line. Ayan. And then, dahil dadaan ulit siya sa pipe, so unti-unti ulit tayo magkakaroon ng decrease in pressure. Okay? So, total energy. So, basically, this is parang pressure na rin naman to, no? Okay, so, total energy grade line, then hydraulic grade line. Okay? So, since meron tayong constant diameter, so constant yung velocity, so this should be equal to v squared over 2g. Then, itong height na to, is the same pa rin, v squared over 2g. Okay? So, yan yung sa head added. Okay, so, ito yung itong height na to. Yan. So, ito yung head ng pump or head added. Yan. So, kung turbine naman, so, kumukuha naman ng energy yung turbine doon sa energy ng flow. Then, again, kino-convert ngayon into electricity. Yan. So, kung meron tayong pipe, meron tayong turbine, then, okay, so yung energy grade line, so of course, meron tayong loss. So, mag-slope pababa. Okay? Then, dahil may turbine, kumuha siya ng energy dun sa flow. So, bababa naman to. Okay? Then, duman ulit sa pipe. So, magkakaroon ulit ng head loss. Ayan. So, ito naman, yung head extracted. So, yung E is extracted. So, kumuha siya ng head. So, itong decrease natin sa hydraulic grade line. So, Yan. So, ito yung head loss. So, dito, meron din tayo ulit another head loss. Okay? So, yan yung energy grade line with and without head loss and yung merong pump and turbine. Okay, so let's talk about yung head loss. Major head loss, meron tayong minor head loss. So, yung major head loss, so galing to sa friction between the liquid and yung pipe wall. While yung minor naman, ito yung mga head loss dahil sa change in direction. Kung may sudden change in direction o kung naka-bend masyado yung pipe natin, or pwedeng change in diameter, or kung meron tayong mga dinaanan na valve dito. Kung may valve dyan. So, of course, so basically change pa rin yun ng diameter. Or sometimes, sa mga sprinkler system, naglalagay tayo ng mga flow control devices tulad ng orifice. So, kung ito yung cross-section ng pipe, okay. So, syempre malaki yung pressure doon sa di ba? Masyadong malaki yung, especially sa sprinkler system. So, kung galing sa baba yung pump, okay, tapos ilang floors yung sinaservan mo, maraming floors yan. Okay? So, kailangan mong meron tayong required na pressure dito sa pinaka dulo na sprinkler head. So, may required pressure yan. So, para ma-reach natin yung pressure doon, so dahil tumaas yung elevation natin, sabihin kung may required pressure dito, so mas malaki pa yung pressure na nandito sa lower floors. Okay? So, kung mag-discharge nyo ito, baka naman sobrang lakas naman ng discharge. So, kaya naglalagay ng orifice. So, kung ito yung pipe, bawa lang, So, naglalagay ng, para lang naman siyang plate na may opening. Ayan. So, pinapaliit yung cross-section. So, para mas pigil yung labas ng tubig dito. Hindi na siya yung sobrang lakas na ng buga ng tubig dito sa papunta na sa sprinkler head. Ayan. So, parang ganito yung pipe. So, merong orifice. So, nire-reduce niya yung opening dito. Okay? So, yan. So, meron din siyang loss dahil dito sa sudden change ng diameter. Kung i-consider natin yan dun sa pipe, change ng diameter, tapos meron kang valve, tapos baka nilakayan mo ulit yung diameter mo. Ayan. So, yung energy grade line, so dito mag-slope siya pababa, tapos dahil meron kang change in diameter, magkakaroon ka ng minor head loss, and another head loss, pababa ulit yan, then meron kang valves, and meron ka ulit minor head loss. Ayan. Okay? So, kung halimbawa naman na ginawa mo tong pump, so yung hydraulic grade line natin, so bigla ito mag-increase, punta rito, then head loss ulit due to friction, then meron tayo ulit na change in diameter, so minor head loss again, then another head loss. So, ganyan yung magiging itsura ng ating energy grade line. Okay, so that's the concept or mga theories dito sa ating fluid flow. na i-apply natin sa problem solving. So, which will be siguro in the next video na lang. So, medyo mahaba na yata itong video na to. Okay? And if nagustuhan nyo itong video, so please like and share. Kung natuto kayo sa video na to, so please consider subscribing. Okay, so again, I'll see you on my next video para sa mga sample problems.